Welcome to Xerox Unstuck. Today, valid anagram. Are two strings just rearrangements of the same letters? We'll solve it two ways, in Rust, the easy sort and the faster counting trick that's 15 times quicker, beginner friendly. Listen and say learn. Same letter, shuffled. Now that's an anagram. Rat and Char are not. Let's teach a computer to tell the difference. Fast! If you like these breakdowns, a quick like helps. First, what an anagram really is. Two strings are anagrams if they contain exactly the same characters, the same number of each, just in a different order. So the real question is, do both strings have the same letter counts? The easiest approach, sort the letters of both strings. If the sorted versions are identical, they're made of the same letters, an anagram. In Rust, collect each string's chars into a vector, sort both and compare, short and correct. Anagram true, rat car false, listen silent true. And on 1,000,000 characters, sorting takes about 16 milliseconds. Correct, but sorting is on log n. We can skip the sort entirely. Just tally letters, add 1 for each letter in the first string, subtract 1 for each letter in the second. If every count lands on 0, they matched perfectly. It's an anagram. For lowercase letters, we use a fixed array of 26 counts. Each letter maps to an index, C minus the byte for atsenaris and e plus 1 from the first string minus 1 from the second. Then we just check that every one of the 26 counts is 0. If any letter is left over, the strings don't match. No sorting, 1 pass each. Same answers on 1,000,000 characters, just 1 millisecond, about 15 times faster than sorting. From on log n down to O1. Counting touches each character once instead of sorting, so it wins as the strings get longer. One free optimization. If the two strings have different lengths, they can't possibly be anagrams, so we return false immediately and skip all the work. Trace rat versus car. From rat r rt each plus 1. From car c a r each minus 1. A and r cancel to 0, but t is left at plus 1 and c at minus 1. Not all 0, so not an anagram, correct? The fixed array of 26 is fastest, but assumes lowercase a to z. For arbitrary Unicode, emoji, accents, anything, use a HashMap of char to count. Same plus 1 minus 1 idea, just a more general container. Counting is O(n) time n with the fixed array O(1) space, just 26 slots no matter how long the strings are. Sorting is O(n) log n. The counting approach wins on both. Common mistakes. Forgetting the length check, ignoring case or spaces when the problem cares about them, and using the 26 array on input that isn't lowercase, which will panic on the index. Recap. An anagram means identical letter counts. Add 1 for the first string, subtract 1 for the second, and if everything is 0, it's an anagram. O(n) and it beats sorting. Quick one, if these help you, the wallet's on screen and there's a Ko-fi link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe. A new coding challenge every day. See you in the next one.